Good evening, doctor. My name is Irina Mariel, and today I'll be demonstrating for Lab 2 Part 1. So basically, we will enter our high level language into the program compiler. So once we have done with the coding, then we will press compile, and it will display the output at the program code. So basically, this is our main program. Then interrupt 1, 2, and oh sorry 1, 2, and 3. So as for our main program, where we'll move the value 1 to register 2, and um, the JZR74 means it will jump to the address 74 when the Z value equals to 1. Otherwise, it will jump back to the address of 60 before it goes home. So once we are done with the coding, we will then load in the memory. So the program will, our CPU instruction will be copied into here. So we shall reset the program and we will run. So as you can see, this is without the interrupt where our R2 will remain the value 1. So so to trigger the interrupt, let's say that I initiate the first interrupt vector where I trigger. So you can see here, it the first interrupt is this coding. So it will temporarily move the value of 6 to register 2 and display this is interrupt 1 at our input output console, because the address number 6 says that it will produce the output at the memory address number 6. So here's the program data memory, and same goes to the second and third interrupt as well as we triggered. So if we trigger the interrupt 2, it will show the same where we will move the value of 26 to R2 before it returning back to the value of 1, and then it will um, display the output. This is interrupt 2. So as for interrupt 5, when we triggered, it will move the value of 46 to R2 before turning back to 1, and it will display at the program data memory of number 46, which is this is interrupt 5. That's all for my demonstration for part 1. Thank you. Okay, next is for part 2, where we will start with the first interrupt method. So we will insert our high level language and compile it so that it can display at our program code here. So one it is then we will load to the memory, and first we click the reset program and we click run so we can see our input and output. So the program will start, and we shall insert our input. So I'll insert as K. So as you can see here, it will display the program starting just like in our program that we have coded previously, and the the dot will continue displaying until our register 1 count to 100. Then it will then display our input. So let's wait until 100. So as you can see here, once it has reached 100, then it will display our input that we have key in, which is K, and then only it will display the program ending. So this is basically what we call hold interrupt, because we have to wait until our input is displayed. Alright, next we shall move on to our next interrupt method, where as the usual we shall code in our program source at the program compiler, and then we compile the high level language so that it can display at the program code output. Then we shall load in memory, so it will be loaded at our CPU instruction. So as usual, we reset the program, and then we shall run and observe the input output console. So as you can see here, it display the program starting. So if I input the letter A, it will directly display the program, and it will end right away. So that is the difference between the hold interrupt, and this is called the trap interrupt. So the difference between both interrupt is the hold interrupt will basically, since we program it for our vector to count 1 to 0, then it will count until 1 to 0 even though we have insert our input. So once, sorry, 1 to 100. So once we have, once the program display the dot until 100, then it will then only display our input. Different for the trap interrupt, where it doesn't need to reach until 100. So as soon as we interrupt by key in our input, then it will directly and display our input and end the program. That's all for my demonstration. Thank you.